The broadcast is now starting. All attendees are in listen-only mode.
Well, good afternoon, everybody, and welcome along to DBA Fundamentals Down Under for December. We've got our last session for 2019, and for this session, we've got Gerard Wolfart from across the ditch in New Zealand giving today's session. Gerard's going to be talking to us about scalable data pipelines with managed Data Lake on Databricks and Azure Data Lake. Now, before I hand over to Gerard, I do have a couple of housekeeping slides to run through. Then I'll hand over and the session will be his. So first up, we need to big thanks to our sponsors. Without our sponsors, it makes it difficult for us to hold these sessions each month for you. We're lucky enough here at the DBA Fundamentals to have two sponsors, being SentryOne and we also have, well, that's on the next slide, but if you haven't already been to SentryOne's website, make sure you do go along. They have lots of different feeds, learning materials, etc., that are able to assist you with your data platform learning experience. The other sponsor that we have is DBWatch, and they provide an enterprise manager assisting you with your SQL Server environments. Just like this virtual group, oh, that's a bit odd. Why is that not displaying properly? Let me restart. That's not good at all. Okay, looks like I've had a hiccup with the slide deck. This slide here was going to be showing all of the other virtual chapters that are available with PASS. Make sure that you go to the PASS website and register for any of those virtual chapters that you might be interested in to improve and assist with your learnings. So with that, we'll hand over to Gerard to take us through for this month's session.
Great stuff. Thanks for that, Warwick. Let me just get the presentation up. Hi, everybody. Welcome to Scalable Data Pipelines featuring Data Lake or Databricks 2 and ADLS Gen2. It's a bit of a mouthful, but we'll get into it and we'll talk a little bit more about what we actually mean here. First, I guess we need to get into some shameless self-promotion. So who is this guy doing the presentation today? So my name is Gerard Wolfart. I've been in the data and analytics space for going on about 20 years now. Predominantly started with a business intelligence background and progressively moved more towards the modern data platform side of the world, specifically around the cloud, Azure in particular. How would I describe myself if someone asked me what do you do for a living? I suppose I best fit into the bucket of a data platform architect slash data engineer. I am by no means a data scientist. My place in this world is essentially creating the platforms for the propeller heads that are the data scientists to do their statistical and mathematical magic. I just don't want to waste their time with having to consolidate data and build platforms. That's my job. So that's essentially the bucket that I fit into. As I mentioned, I specialize in the Azure Data Platform suite of technologies. That includes not only the Microsoft owned and built technologies, but also the data platform suite of products such as Databricks and Snowflake and whatever else runs as part of that Microsoft Azure ecosystem in terms of data platform and analytics. So I am a co-founder of a niche consulting firm here in New Zealand called the Data Collective. What we do is we effectively build data platforms and analytic solutions for our customers in Azure, pushing our customers as much towards platform and software as a service as we possibly can, minimizing the need for them to have infrastructure as a service, meaning patching of servers, etc. We feel that by leveraging the great platform as a service technologies that are available in Azure, we can focus on building solutions rather than managing infrastructure. So if you want to know a little bit more about me and what I do, you can go and look at my blog. It's a relatively new blog. I've been taking from the community for many, many years. So I figured it's about time I start giving back. So I've recently decided it's time to start blogging and sharing some of my ideas. Some of the stuff that we'll be covering today, there's far more detailed blogs that's on my blog page where you can go and have a look. You've also got my LinkedIn address there, and if you want to have a little bit more of a look about what the Data Collective do, then I've got our website up there for you too. So diving in first and foremost into the data lake. So I'm going to talk in this presentation a little bit, assuming that we've got a broad range of experience with the various different technologies, from novice all the way through expert. So bear with me if you're an expert. We are going to, start with some basic concepts and things like that to help catch up those who are not familiar with the technology, starting with the data lake. So what is a data lake, right? So if you can see from the definition up there on the screen, a repository for storing large quantities of disparate data sources in its native format, right? Now, that's a mouthful, but what does that really mean, right? Effectively, all it is one architectural platform that will house all your types of data. Now, most of us are familiar with working with more structured data, data that comes from your line of business applications, CRM solutions, ERP solutions, following a tabular structure, right? Rows and columns. We're all familiar with that. I will accept CSVs as a structured data format. However, I think that Excel and those kinds of things, though people think that it's rows and columns, more often than not fall into that unstructured area where they've been manipulated by humans so much that it's not easy to just digest them with a system. Invariably, some level of manipulation is required. Semi-structured, we're seeing more and more of this information. This is telemetry information, typically machine generated, IoT, event logs, web logs, JSON files, XML files, think those kinds of things. Data lakes are good for those too, as well as the unstructured data, the things, like I said, that are typically human generated, right? Tweets, emails, documents, those kinds of things. So a data lake really is a one-stop shop for all things data. The objectives and why these are around, and why don't we just stick with traditional data warehousing, right? And why we don't just do that anymore? Well, the reason is we spent a lot of time in traditional data warehousing approaches trying to understand requirements. And the reality is, as soon as we think we have the requirements down pat, what ends up happening is they change, right? So what data lakes try to do is rather than try to understand all the requirements up front and then saying, all right, now I know what data I need, let's go and say, let's just take the data in its raw format, all of it, and when we can figure out what we need to do with it later, right? And one of the key objectives is trying to make this acquisition of data easy, right? So that we can go and experiment and analyze this data, right? So rather than spending days or weeks trying to get data in, let's get it in real quick so that we can go and experiment and look at what we actually have, right? And this goes for both data generated within the organization as well as external data sources, right? Because we want to take on so much data, we obviously want to try and get as much of it in as we possibly can, right? So we have to have a lake needs to be able to scale for the sheer volume of data that we're going to deal with, right? What we try to do with these is we defer the schematization. In other words, you would have heard the terms schema on read as opposed to schema on write. We don't try to schematize the data as we push it into the lake. We worry about structuring and then curating it for business requirements or for specific curation requirements downstream. With the lake, we just focus on getting it in really quickly as a first step. This allows us to create or achieve faster agility than traditional data warehouse approaches, because we actually get the data in, we get to experiment with it and iterate through that process much quicker than we would with trying to understand it up front, create a model, and then basically that changes on us and we have to go back to the drawing board. This invariably leads to, or naturally leads to, better decision-making ability, right? Because we get to iterate through things and experiment with things so much quicker. And what it also does is, like I said, it opens us up for additional types of data that were historically difficult to analyze and obtain, such as JSON files and XML files, which, as you know, from traditional relational database perspective, doesn't always work so well. I mean, modern technologies are better, but if you think back a few years, these were pretty difficult to deal with. So moving on to my next slide. Oops, bear with me. Just skip through this one. Right, so then we enter with Databricks and Delta Lake, right? So what is Delta Lake? Effectively, Delta Lake is an open source storage layer that brings reliability to data lakes, right? Now, Delta Lake initially was created by our friends at Databricks, and it was known as Databricks Delta. I want to say recently, but it's not so recent anymore. Databricks decided to open source this as a file format, which basically means that you don't have to necessarily be a Databricks user to actually use Delta Lake, right? If you have Spark clusters that you use, on-premise, or you've built your own Spark clusters, you can still use the Delta Lake file format as a storage engine. It doesn't have to necessarily work with Databricks. The reason I like Databricks is it's managed Spark clusters. It's really simple. Like I said, we very much push the platform as a service technology. And because Delta Lake is built by the Databricks team, invariably things work. The Delta Lake features drop first inside Databricks before they actually open sourced. So that's why I like to work with that. Now, what are some of the things that Delta Lake does for us that we didn't get from traditional big data file formats, right? So if you've been working in a database world, you're very familiar with ACID transactions, right? These were not available in the big data world historically, which caused a lot of problems in terms of concurrent reads and things like that, where you could get non-repeatable reads or just queries failing left, right, and center. What Delta Lake allows us to do is we can now get ACID transactions on Spark, right? Serializable isolation levels that ensure that readers see consistent data. So you don't get failed queries anymore when one process is writing and another one tries to read. We now get the ability to do schema enforcement, which previously didn't exist inside a big data world. But we also get the benefit of schema evolution, right? So if you've worked in traditional data warehouse implementations, you would know the pain of someone changing a column name in a source system, or adding a column, or dropping a column, or going from an integer to a varchar data type, and how that breaks traditional ETL pipelines. With Databricks and Delta Lake, we can actually now choose to evolve that schema automatically when it makes sense to, and fail it when it doesn't, right? What we also get out of the box is the concept called time travel, right? Delta Lake will actually keep track of version the data in your file, so that you can actually roll back to a point of in the past, and it also provides you with full historical audit trails, and you'll see some of this in the presentation or the demo that I'm going to be doing a little bit later. In addition to that, we also get the streaming and batch unification. Now, if you think, those of you who are familiar with Lambda architecture, how we used to have a hot path and a cold path, where we stream data in through the hot path and we had to write it to a specific location, and then we have our traditional batch processes that came in through the cold path, and we had to store that somewhere, and then ultimately present a unified picture on the back of that to show unification of our streaming path, or our hot path and our cold path. With Delta, we can actually write streaming data as well as batch data to the same destination table, and it'll still work consistently, which is a fantastic way, and I'll show you how we can do a little bit about that later. And then I guess the scalable metadata handling is one of the more challenging things to do in a presentation. But the point is with this technology is we can scale up and out to our heart's content. We can add as many nodes to our cluster as we need to, and allowing us to process ridiculous amounts of data, and it scales linearly. So really, if you just want to throw more hardware at it to get through big problems, it's really, really simple to do so. And obviously, underpinning all of this as a storage layer is Azure Data Lake Store Gen2, which brings with it some rich security stuff. I mean, if you're familiar with POSIX style access control layer or ACLs, you can actually secure your data lake store at the file or folder level, just like you can with a traditional Windows store, to make sure Windows file share. So we can now secure this all Active Directory, Azure Active Directory integrated. So a really, really secure solution. Super fast. So with that said, let's dive into a bit of show and tell about Databricks and Delta. So we'll firstly go to something that most of us here is probably familiar with, good old Management Studio. So what I've done here is I've created a database, good old AdventureWorks LT, but for the purposes of this, we're going to create our own table in AdventureWorks LT called Test Delta Lake. Now, apologies, I can't exactly zoom the Object Explorer, but if you cast your eyes over this query window here, hopefully you can see what I'm actually doing. So first and foremost, what we'll do is we'll drop and create our Test Delta Lake table. And as you can see here, I've just picked a bunch of random columns. I've prefixed them with some and just a mix of data types in here to show that Databricks actually handles this stuff quite easily. Given it a primary key, so we'll get that created. And now if I refresh this, you'll see that we've got our table, which basically has all the columns as we've just set them up, right? Now let's put some baseline data in here. So I'm just going to pre-populate that with some data, and apologies for this not zooming all that well down here. So hopefully you can see that, but basically we've got 5 rows in here, starting at -1 all the way through 3, which is the data that we've got in here. So this will play the role of the source for our effectively our data pipeline. Now, granted, it's not a huge amount of data that we're dealing with here, but for the purposes of demo, it makes it easier to see what's actually happening behind the scenes. So with that, we'll dive into Azure Databricks. So what you see here on my screen is just Azure Databricks that I've opened up from the Azure portal, right? So it's just a workspace that I've looked at, my Azure Databricks workspace, and I've just basically worked that up. And what I've got in front of me here is a notebook. So for those of you not familiar with the notebook interface, it is a fantastic way to work with code. You can actually document your code as you go through. And as you can see here, I've basically embedded images with just HTML. So I can actually add markup and all kinds of things like that in here and comment my code as I go. So what I've done here is this demo essentially just goes through and show you the basics of Delta Lake, so you can actually see how that works. So let's start with this notebook. So essentially the first thing we want to do is just set some notebook variables, right? So the first thing we're going to do is just set up the connectivity to that Azure SQL database that we just looked at in Management Studio. So for this, we're going to use JDBC, a JDBC connector. For the purposes of this demo, we're using JDBC, and that's just because there's so many JDBC drivers available for Databricks. You can connect to pretty much any relational database that you want to with the JDBC drivers. In this case, we're obviously just going to use JDBC, but typically what you'd use if you're going to connect to SQL Server is you'd use the Spark connector, the SQL Spark connector, which performs a lot better than the JDBC one, and also has capabilities of bulk insert and things like that. But for the purposes of the demo, we'll just use the JDBC driver. Right, so these first things here will just set up the connection information. As you can see, I've just got a SQL username, the actual server name that I'm connecting to. So as you can see, that's an Azure SQL database, the database name that I'm connecting to, the query that I actually want to run against that database. Notice the filter criteria here that I'm only pulling the records that are greater than -1. So I'm leaving some records behind in my source. And then the traditional SQL port 1433 that we're connecting to. The secret config section that you see here, basically what I've done is I've stored all my secrets in an Azure Key Vault. So Azure Key Vault kind of falls beyond the scope of what we're trying to do today, but it's essentially, for those who don't know, it's a secure store where you can put certificates, keys, secrets, etc. And what I've done here is I've actually stored my SQL password in here. So I've set up they call it a Azure Key Vault secret backed scope that I've set up here. So this is actually going to connect to my Key Vault and retrieve my password for me for that secret in there. The other thing that I've done here is I've basically just set up some ADLS configurations, right? So this is basically just going to my ADLS storage account and saying what the file system is that I'm using, right? In this case, I went and in my storage account created a file system called persisted. So if you can see, this is just Azure Storage Explorer. Think of it as something similar to Windows Explorer, but you're just looking at big data storage or Azure-based storage solutions. So as you can see, I've got storage accounts and disks and Data Lake Store Gen2 and Cosmos accounts, etc. So in my Data Lake Store Gen2 account here, you can see I've got a number of different containers. Containers are just file systems, right? The term is essentially used interchangeably depending on which API you use. So as you can see, in this case, we're just going to look at the persisted file system, and that's what this variable is referencing here. I've also created a database inside Databricks. Now, this is just a logical database container. So you'll see there is my database here. Currently, I've got no tables in it. Now, a database in Databricks is not what you might think the traditional SQL database is. It's basically just a container. It's essentially just metadata that says, all right, this is how these bunch of objects are grouped. The data isn't actually stored inside Databricks. It's stored in that storage account. I've got a transient view here, which I'll explain a little bit later what that's for. And then I've just basically put in here and say, all right, where do I want to store this information? So what I've done here is I've actually mounted my ADLS Gen2 account to the Databricks file system. Again, this is something, if you want to know more about this, I've got a detailed blog post about all the ways in which you can access Azure Data Lake Store Gen2 from Databricks. There's a number of different ways you can mount the storage account. You can connect to it directly. We can use AAD pass-through authentication. There's a raft of different ways. For the purposes of this demo, I've just mounted it to the Databricks file system, which basically is the equivalent of mapping a network drive to a Windows server, right? So it's just I can interact with the drive as if it's a local drive by using that syntax over there, right? So that's effectively what I've done here. And then I've just got some Delta Lake config tables. So look, it comes from the DBO schema. I've underscored it and said that's the table name. So that's ultimately the table. And what I've done here is just a join condition. So I've just said the primary key of this table is SumID. So sync.sumid equals source.sumid, and that you'll see later where this is used. Don't worry too much about that one. It's not used for the purpose of this demo. So what I've done is I've created a cluster. Again, if you want to see all this stuff, you can go and look at the blog post. I've got a running cluster already that we'll use in the background. So we'll basically just initialize these variables quickly. So now all of this is just stored in variables. So like I said to you, what I'm going to go do now is retrieve the secret from my key vault. So this is just going and saying, hey, go get from key vault where the scope is this, the secret name that's this, and that will store that in the JDBC password. And then I'm basically just creating a JDBC URL and some connection properties here using some string interpolation, as you can see here. Pretty simple stuff. And what I'm going to do now is say, all right, now take this connection that we've just created, execute the query against my SQL database, and load that data into a transient view, right? So a temporary view inside Databricks. And what you can see now is it's created this data frame, and that schema actually lines up with the schema of our SQL database, as you can see here, right? So now I can go in here and notice, this is probably one thing I need to call out here. Notice the notebook type that I've created inside Databricks is actually a Python notebook. You can create notebooks inside Databricks in a number of different languages, but the beauty is you can toggle between those languages as well. So currently, you can do it in Python, you can do it in Scala, you can do a SQL notebook, and you can do a Java notebook. And I believe they are actively working on for Azure Databricks, working on a .NET version as well. So you can, if you can code .NET, you can write that language in here. But I can swap between languages as well. So in this case, I've been writing Python up to this point, but now I can, with that little smart command there, just basically say, all right, now I want to write SQL now. So for those of us familiar with SQL, I can write that now, and that's literally just return the data, same way this query did here, from my SQL database. So as you can see, the query was filtering that row out, and what we've got in Databricks now is 0, 1 through 3. So that is literally just a pointer to the Azure SQL database and pulling that into Databricks, right? No different to any other SQL or client query tool. All right, so what we want to do now here is and this is where I'm talking a little bit more to the advanced users who are using Parquet files. Parquet is a file format, big data file format, really optimized for analytical workloads, for those not familiar with it. it's basically columns, it's column store files. So if you're familiar with column store databases, think of Parquet files as column store files. Really, really efficient, compress really, really well, and has become the pseudo standard for big data file formats for analytics, right? So if you're familiar with Parquet file formats, this is how you would create a table, an external table, if you will, where the metadata lives inside Databricks and the actual physical data lives in our storage layer. So if I was to execute this, and I'm basically using a create table as statement here, right? So I'm saying, right, create this table using the Parquet format in this location in my mount point, which I'll show you what that looks like, as select star from that transient view. So take the data in this view and create me an external table, right? So if I execute that, what's happening here now is the select statement pulls that data and actually writes this out to my storage layer. So if I go into my persisted zone now and I refresh that, what you'll see here is this, based on that file path that we've got here, I now actually have AdventureWorks, DBO, and there's my table. And in here, it's actually created a snappy compressed Parquet file with some validation data and make sure some hidden files inside the big data file formats, inside blob storage accounts. If you prefix them with an underscore, they're effectively hidden files. Storage Explorer, you can hide or show them, so I've shown them, but typically that is your data file that you see there. Parquet file, snappy compressed. If you look at the file size there, it's 2.4 kilobytes, right? So really nice and small and compressed, right? The nice thing about Parquet files as well, for those who don't know, the schema is actually embedded in the file as well. So you don't need to have an external schema definition for Parquet files. It's embedded and they're actually strongly typed as well. So it'll honor and prevent you from putting nulls and things like that into the Parquet file format. So how do I go from Parquet to Delta? It's really simple. It's the exact same query. The only difference is instead of saying Parquet, I say Delta. The rest of the query looks exactly the same. So like that Parquet file that I've created, the Parquet table that I've created there, I'm just going to create a Delta table of the equivalent. So I run that, and in my storage account, if we go up a level, what you'll see now is a Delta Lake table. And how does that differ from the Parquet file? So we still have our snappy Parquet. As you can see, the data is exactly the same, still uses the Parquet file format under the covers, 2.4 kilobytes, but what it now gives us is this beautiful thing that's called the Delta log, right? Which is where all the ACID transactions and the time travel and all the benefits from that come from. So that's just a cyclic redundancy check file. Don't worry about too much about that one, but this is really where the magic happens. That JSON file will tell us which versions are applicable at this point in time when we do queries and which versions are applicable at a point in time. But I'll show you a little bit more about this. Right, so now that we've created our tables, let's see what the data in those files actually look like, right? So I'm now just going to write a simple SQL statement that says, from my persisted database, which you'll now see I've got two new tables created here, the metadata for them. That's the Parquet one, and that's the Delta Lake one. So I'm going to query the persisted from the Delta Lake one, and this is basically now retrieving the data from my storage account and displaying it here. So this is actually now querying the data as it's stored. So as you can see, exactly the same result as in my SQL database, right? So it's just written that data out of the data lake. And that's how easy it is to basically ingest, copy the raw data into your data lake, right? So now let's have a little bit of a look at evolve or move on our source system, right? So let's insert a new row, update an existing row, and delete an existing row in here, right? So I'm going to run that query, and I'm going to show you the three different result sets, right? So in the first one, it's inserted that new value 4. I'm hoping that you can see that. It's not too small on my screen. So it's inserted a new value with some ID 4. We have at the same time updated this value here, which now says update value for some ID 1. And in the final query that we've run here, we've deleted some ID number 2, right? So what we want Delta to do now is basically insert the new row, update that row, and delete this row here, so to make the data look exactly the same way as it does in our source system. Now, in order to do that, I just need to refresh my data frame that reads from my source system. So the only thing that's necessary to do is just refresh this. just to make sure that my transient view is refreshed with the latest data. So if I query that now, you'll see that record number 4 is here, the updated value for sum ID 1 and sum ID 2 is no longer in this result set, right? So sliding down a little bit to this point here, let's now perform our insert, update, and delete actions as required. Now all that's required, if you're familiar with SQL, the merge into statement, Databricks have a similar, or Databricks has a similar SQL syntax for that. So what we can write here is just say, basically merge into the test data log as sync, using my transient view as the source. That's the condition that we talked about a little bit earlier. So basically just specify the key to merge on. And when it matches, update set star, right? So basically update everything. And when not matched, insert the records, right? So if I execute that, it's going to go away and do some work. And the same has to be done for the delete. So once that merge into is done, so this will deal with my inserts and updates, and then that will deal with my deletes. So as you can see, really simple SQL statements, right, that we're executing here. And when that's done, we'll go up here. Bear in mind, I'm using a MSDN cluster here, so it's very, very minimal, simple, tiny little cluster that I'm running here to keep the cost down. Can't have too expensive clusters running for demos. They just eat through your Azure credits too quickly. So you remember that we had a single file in the Delta log previously. So this is just the query that I wrote here in Python to basically go and pull back the number of versions that we had for this. And that effectively is the same number of files that you'll see in here. So you'll see JSON 0, 1, and 2. This just goes and pulls that back. Now, what that means is that's the original version of my data. That was the version that was created when I ran the merge into statement. And that is the version that was created when I ran the delete statement, right? Now let's go see what that looked like. So if I go back here, you have this handy little syntax here where you can go and query your Delta table as at a specific version, right? So in this case, we're going to query, hey, what did my table look like at version 0, which was our initial load, right? So as you can see in here, when that executes, we still have all our base values, 0, 1, 2, and 3, all with the base values and the stock standard results, right? And that is also the same result that we'll get from, yeah, that's the 0, 2 is the current version of the table, right? So if I query 0, 1, that is after the merge. So what we should see in here is the insert and the update. And as you can see, there's my update value for sum ID 1, and there is my insert value for new value for sum ID 4. And if I now query version 2, or the current version, you'll see that sum ID 2 has now been removed here, right? So that reflects it. Now this shows off the time travel capability. Historically, what we had to do was write, slowly changing dimensions and things like that to achieve this. This doesn't mean that you can't do slowly changing dimensionality. Absolutely, you still can. If you keep an eye on my blog post, I'll show in future scenarios how you can actually do this. Still use Delta Lake with slowly changing dimension and get this as an additional layer of extraction. Now, querying the version as of is not the way that you typically go about that. Obviously, for the purpose of a demo, it makes it easy because I don't have to keep track of the exact milliseconds that this was done. But there is another syntax to go do time travel, and you basically go based on a timestamp. So you can say, select from this table where the timestamp as of, and then you give it a date and time, right? Which is probably in the real world, the more likely way that you're going to use this. So it just shows that there's multiple ways that you can actually query the Delta files, right? So with that said, at this point, I think we'll pause for a little bit of questions if there are any, Warwick, before we dive into a little bit more.
At this stage, Gerard, we've got no questions, so if you feel free to continue.
Okay, perfect. Don't know if that's a good or a bad thing. Hopefully there's some questions that comes through to the closer towards the end. All right, so in a nutshell, you've seen this is effectively just SQL statements to go about this work, right? But what we can do now is where the real power comes from and where the scalability comes from with this is we can make these queries dynamic. So I can use a single notebook to ingest every single table inside my SQL table by making a few things parameter driven, right? Effectively, if you think about the whole dynamic SQL ways that we used to do things, but it's really, really simple in Databricks. At the same time, I also talked to you about evolving the schema automatically for the source system, right? So let's see how that might work in the real world here. So what this example does here is I'm basically going to go and say, all right, add a column to my source database. So I'm going to source table. So I'm going to take this data lake table and add a column of varchar in 50, right? And then I'm going to put a new row inside that column, right? Or a new row into the table, which puts data inside that column. So if you look at this here now, what you'll see is there is the new column that's been added, and there is my new row that's sitting in SQL, right? Now, if we flip over to Databricks again, the only thing I need to do is I have to go refresh my source data frame and my temporary view that's created off that data frame to show me the new data. So if I refresh my transient view now, and this is now where the transient view comes in. So you remember earlier when we set up some variables at the front here, I picked my view name, right? And I picked transient view deliberately because it's a transient view for any source table. I could have gone with test delta lake here, but the reality is what I want to do ultimately is just have that be a generic source table. You can go with generic source or source table or whatever you want. I just went with transient view because it's kind of like typically comes off the transient zone in your data lake. That kind of reminds me that I wanted to talk to you a little bit about the zoning inside your data lake. I'm not covering it much here, but you notice that I'm talking about the persistent zone and the transient zone a little bit here. I've got a blog that talks about zoning inside data lakes at length. So if you want to know more about how we structure data lakes in terms of zoning and what goes into each zone, what the purpose for each zone is, yeah, feel free to go to my blog page and have a little bit of a look at that blog post. So what we've done here is I've just gone with transient view, right? For the purposes of this conversation, and that's why this view is select transient view. So as you can see, that now has my new column and the new row for that column, sum ID value 5, and new column called new column, right? So now let's look at evolving the schema, right? So what I need to do to actually evolve the schema is I basically want to do the source data frame comparison schema of the source data frame and compare it to the sync data frame or the target, right? Sync/target data frame. So what I'm going to do here is I'm just going to read in the sync, as in the data as it exists in my Delta table at the moment, into a data frame, right? Now, what you'll notice here is I'm using this little technique called string interpolation, right? So if you're a conventional programmer, this is bread and butter stuff for you. All I'm doing is I'm saying, take the variables that I defined in this little cell up here, right? For my table name and my database name and things like that, and just replace it into this string at the bottom here, right? Effectively making this a select query that can run on any given table, right? So, but in this case, it's still working on our test Delta Lake table. As you can see, schema is our test Delta Lake table, right? Now, all I'm doing in this step here is I'm basically saying, all right, take the source schema, the fields of the source schema, and put it into that. Take the target schema and put it into that variable, and then tell me whether it's the same or not, right? So it's fairly simple programming this stuff, and just says to me, all right, clearly the schemas do not match, and they don't. So set the variable to schemas match equals 0. And I use that parameter here in this little query here, which basically just says to me, all right, if the schemas don't match, run this code, otherwise don't run it. So it's pretty basic stuff. Even though it looks complicated, if you go through this, you'll see it's really simple, just conditional logic to either do something or don't do it, right? So what I do now is I just loop through the schemas of my source and my schema, and my source and my target, sorry, a source and my sync, and I basically add the columns to my sync that appear in my source that are not there, and vice versa if it was deleted, right? So that's all this code does. It looks very complicated, but it's actually really simple, right? Most of it is just conditional logic to actually loop through and do this. So what I'm going to do now is run that code, and what this will do is it'll actually go and append columns to my sink, right? So as you can see here, the merge schema looks like this, right? And my new column has now been added to my sink. So that's the merge schema, and my sink schema now has the new column, right? Now, what has that done in my Delta log? So if we go back to this query here, we'll see now a new version that's been created here, right? And if I now query version 3, you'll see that it's now merged the schema and added my new column into my sink. The new row has not been added yet, but the schema has been merged, right? And what I've done now here is I'm basically saying, all right, the schema has been merged. Now determine whether there are actual records to insert or update. So that's just a query that I do to say to me, like, look at the source data frame and look at the target data frame and tell me whether there's something that's different, right? And you can do it by the simple subtract function, right? I could still have gone and written a SQL statement in here, but because I have both data frames and that subtract behaves like a not exists in SQL terminology. And as you can see, I've just shown for the delete count, I've still used the SQL syntax. I could have just as easily done this up here. And that's the beauty of the Databricks and the notebook interface, right? Is I can have a mix of Python and SQL and Scala and R, all kinds of different languages in here, whatever you feel comfortable with writing, and you can swap from one to the other. So as you can see here, this is another way of calling a SQL statement, right? So rather than they have the percentage SQL, I can actually say spark.sql and then just literally put in a string, you know, the SQL statement here. So this is basically going to try and see if there's any deletes. We didn't delete anything, so this record count should be 0. And now instead of having my merge into and my delete statement written like I had them previously here, I've basically just wrapped them into some padding to say, look, if there's something to merge, if the merge count is actually, yes, there is something to merge, then do this, otherwise just don't even bother. But effectively it's the same code, but notice what I've done here with the string interpolation again, right, is I've made this completely dynamic. So this code will run for any given table in that database, right? And if I run that, what you'll see here now is a merge happening. And if I now go and look at how many versions I have in my Delta table, I have a new version number 4. And if I query what that version actually looks like, you'll see that I now have my new column added and I have a new value in that column. And I can still go back to version 3. And I can still go back to version 2 and query the data as at that version of the file, right? So, and I can still go back to the original version as well. Right, now we'll go back and evolve the schema one last time, and this is one of the really painful ones that you often run into with source systems, where a column disappears from the source system. Now, in this particular use case, the code that I've written, and you don't have to write it the same way, that's just the way that this particular scenario played out. I always wanted my sink table to contain the superset of columns that was ever present in my source system, right? So if that column existed at some point, I want to keep it there and maybe just populate it with nulls going forward, but show that at some point that there was a column called this and there was data in it for previous versions of that file. But in this case, what you'll notice now is we've gotten rid of our sum date time column, right? So if sum date time is gone now, and if I refresh that, you'll see that we have our new column, but sum date time is gone. Right, so that's what's in SQL now. Now again, we go back to Databricks and we refresh our source data frame and our transient view or a temporary view. And if I select that now, you'll see some date time is now missing from my source system, right? So we'll go back to this workspace and we'll read in the latest version of our sync table, in other words, the one where we've now appended the column and added a new row. Again, we run our comparison to see if our sync and source schemas line up. And again, they don't, because we know that we've got one column less in the source now. We run this little code here, which will run now, instead of, so last time it merged the sync Delta Lake schema. This time it's going to merge the source, because the sync will now have more columns than the source. So as you can see, it's plonked the sum date time back onto that list, right? If I run this now, you'll notice that there's 5 records that's different, right? In the subtract. And that is actually, may sound funny to you, but the reality is because we actually had values in here previously, right? Which are now all nulls. And that's the reason we're actually picking up 5 rows for changes. So if I was to go and query what my version 4, I think it was, yep. So version 4 of my table looked like. In some daytime, we actually had values, right? But now in our source data frame, we effectively have nulls in there. So what our merge count is picking up is that, hey, you used to have values in here and now you have nulls, right? So that's why that's picking it up like that. And effectively, we have 0 deletes. And we're going to run this code again, which will now merge in those 5 records. And at the same time, create us another log version or a Delta log version of this table. And if we query as at, and you should see a version 5.json right now. And if I query at version 5, you'll now see nulls for the sum date time value. Now I can still go back, and at version 4, I can go and query this. Now the nice thing here is if someone accidentally deleted a column in a source system and the intention was not for that to actually happen, it's really easy to create a new table now from this using that create table as statement, because I can basically create a new table and then say select from this table as at version 4 and just create it like it existed yesterday or at the previous load or at any previous version of my Delta Lake. So it gives you that out in case of disaster. You can just time travel back to a previous version of the table and restore to that point in time. So really, really good stuff to have around. So I guess that concludes the little demo that I had on the basics of Delta Lake and how we can actually deal with the schema evolution and the schema enforcement and things like that. So I guess, Warwick, we can take another break here and see if there's any questions before I dive into the streaming and batch combination.
Okay, so we do have 2 questions for you. So the first one, do we need slowly changing dimensions going forward, or does time travel completely replace it?
Okay, so it depends, right? If you're using slowly changing dimensions to track history indefinitely, in other words, you want to keep all your information, in terms of storage, if actual file storage on disk, this ends up being cheaper than keeping your Delta history. Keeping in mind that the way this works behind the scenes is you're actually writing the full version of the file again. So it reads everything and writes a new file. In big data, there is no updating of existing files, right? It reads the files and writes them again. Now, you can go and do cleanups to get rid of older files and things like that. So you can set your Delta Lake retention policy, but because it writes the files every time, or your table contents every single time, growth can be relatively bigger, or can be bigger in comparison with the pure merge functionality versus the slowly changing dimension functionality, right? So what I typically do is if there's a requirement to keep data indefinitely, you can use Delta combined with the SCD approach and set your Delta log retention policies to something like 30 days, which gives you the best of both worlds. You get your slowly changing dimensionality with your start dates and end dates and your is current flags and things like that, but you have the fallback of a rolling 30 days of, if that process fails, you've got Delta to fall back on, right? So you can do it as a best of both worlds. If you don't have a requirement to keep your data indefinitely and say you want to keep your data for the last year or the last 2 years, depending on your data volume, then this approach is more than efficient, right? More than sufficient. And when I say it inflates storage, you've got to also remember that when we're talking about blob storage, we're talking about $30 per month per terabyte. So we're not talking about a huge amount of storage anyway. Even if you go into the multiple terabytes of data, you're still only talking about $30 a terabyte, right? So it's fairly small around what you need to keep. And then you have this, like I said, there's and it's kind of beyond the scope of what we're talking about here, but you have optimizations and vacuums that you can do. So you can recreate files to optimize them again and then vacuum out the old ones. To reclaim some of that storage space as well. So there's maintenance processes that you can do to manage that storage growth as well. Hoping that that answered your question.
Okay, and the second question is, what is the reason to separate out insert, update, and delete?
Okay, so that's just the reason, the way in which the merge function out of the box works inside Databricks. And I think you have the same challenge in SQL anyway. SQL won't do the deletes as part of a merge statement. You actually have to have it as a separate command. So when I do, so this is only for this load pattern, right? So if you do the slowly changing dimension load pattern, and if you want, I'm going to write a blog on it, a detailed blog on this as well, but I think Databricks on their Databricks documentation site have an example of this as well. You can do soft deletes, and you don't actually have to do hard deletes like I'm doing here, right? So you can still just have a flag that you set. So effectively in that case, you only need the merge into statement, right? Because you're not actually physically deleting something. You're just setting a flag to show that it's soft deleted. So it really depends on your use case. You don't have to have deletes at all. This is just physically removing the data from that file. Very useful if you're working in the European Union with GDPR and things like that, where you actually have to go physically remove data for users if they don't want to be in there. In those scenarios, you can actually use delete to physically go and remove it from all the various different versions that you have inside your lake as well. But that's just the way that this works. In SQL, you would have had to write it in 2 steps like this as well, because the merge doesn't actually do deletes. It just does upserts, basically. Hoping that that answered the question.
Okay. Yeah, so if you wish to continue, all good.
Okay, perfect. All right, so let's dive into the next workbook here. Now, here we're moving away from data lakes a little bit and kind of going to generate a few things on the fly, because the intention here is now to go and show you how Lambda architecture can be implemented using Delta Lake, effectively combining stream and batch, right? So what we do here is we've got this little, all I'm doing here is just some file system initialization. So I'm just going to clean up. I create a Parquet file path, a Delta raw path, which is just the raw data, and I'll show you a little bit about an aggregation that I'm going to perform on here, right? So what historically used to happen is if you tried to load batch data and streaming data into the same destination, you couldn't do that historically, right? You had to have 2 separate tables as a destination, and then try to combine that at the end. So if we tried to implement this as traditional Parquet, and all this is doing is just a little function that's going to create me some sensor data. It's going to create 100,000 rows. 50% of them is going to be close action, others going to be open action, and it's just going to add some date stuff on it. So as you can see, I'm just generating some data and random device IDs basically, right? So I'm going to run that code there, and it's just going to create it. So if I write that data that I've generated here now out into a traditional Parquet table, then that writes that out now. And you can see as the file format is Parquet, and I'm just partitioning it by date, which basically just means separate the files and split them off by date. And if I read that data in now, you'll see all I've got in here is a bunch of sensor information with some generated dates, right? Open, close, 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 etc. Right? And if I group that by now, you'll see I have 100,000 records, 50,000 open, and 50,000 close, right? So that's just the data set that I've generated. Essentially, that's all that bit does. Now, let's try to stream data. So this, all this is doing here is generating some stream data. Now, typically, this is just making it up on the fly, but you can read this from a Kafka stream or from an event hub or an IoT hub or whatever else is feeding data, a service bus of some sort, whatever is feeding you the data, right? In this scenario, I'm just making it up, right? I'm just generating some data because it's just to show you what a stream would look like. So I'm starting the stream now. So as you can see, that's actually generating a stream of data, and this will just keep running in the background. And if I query that data now, this is trying so that data is being pushed to the same, or trying to push it to the same Parquet table. But what you'll notice now is where I had my open and close here, that's now gone, right? So that just shows that we couldn't do this before we had Delta, right? We couldn't write it, batch data and stream data to the same target table, right? We had to actually physically have separate tables for streaming and a separate table for the batch stuff, and then try to stitch it together after the fact, right? Now with Delta, we'll use the same source data that we had here, our sensor set that we generated here, and we'll start a new stream from Delta and basically try to push this in, right? So all I'm doing now is just writing that same 50,000 open, 50,000 close to a Delta table. So as you can see, raw data.write.format Delta partitioned by dates is effectively the same thing. If I query that, you'll see it's the same result set, but it's now coming from a Delta table. Right, 50,000 open, 50,000 close, right? And now I'm going to start a stream that writes to that Delta table, right? And this is where the magic happens, right? And this is really, really cool stuff if you have to deal with this problem of streaming and batch data coming in at the same time. So if I run this query now, you'll notice that my 50,000 open and closes are still there, but it's now going to keep appending my new opens to the back of it, right? Now, this is pretty awesome stuff because I can leave this stream running for data trickling into my Delta table, but I can now say, all right, I'm going to use that Delta table not just as a sink, but I'm going to use it as a source for a downstream process at the same time. So what I'm going to do now is I'm going to create another stream, right, to do some data aggregations, right? So I'm going to start that stream and say, all right, aggregate my data by action, by date, by device ID, right? So I'm starting a stream that's now using this table as a source and aggregating the data, right? And if I query that, you'll see I can now keep both those streams are running. So I've got basically two streams, one reading from a source, from a Kafka feed into a Delta table, and then using that raw Delta table to run another stream that aggregates the data into a real-time feed. Now this is being presented inside this Databricks grid, and as you can see, there's just appending data. Every time I run this query, it appends the data. But this doesn't have to do this. I can now feed this straight into a Power BI report or whatever your reporting platform of choice is, right? Feed this real-time data, and then I can supplement it with batch information at the same time, right? Just keep throwing data at it, whether it comes from the stream or comes from the batch. So it gets you a really, really, really reliable pipeline based on streaming and batch combined, right? So this is amazing stuff, right? And you can imagine the type of analytics that you can perform with this kind of workload. So that's just a quick way to demonstrate, you know, essentially the combination of streaming and batch inside the same Delta table. It really is a game changer for data lakes. What I see more and more is all our clients anyway are doing their data engineering and their heavy lifting using technologies such as this, Databricks and Delta Lake, to get the data ready, curate the data sets, and then push it into their serving layer of choice, whether that's a Snowflake or a SQL Synapse Analytics, or for smaller data sets an Azure SQL database, or whether it just ends up being straight into a Power BI model. It really is horses for courses, and you can do from here, you could feed data into any one of those solutions, or even non-Microsoft products if you feel like a Tableau or a MicroStrategy or whatever. It really is up to you, but the power and the scalability of something like Databricks is just incredible. And I guess that's pretty much where I want to wrap it up. I think if there are any more questions, I'm happy to take them now. But I see we're almost at time, or we are at time.
Okay, thank you, Gerard. We've got a couple of questions here. So while I'm asking these, if anybody else has got a couple more questions, feel free to put them into the questions window and I will ask them. So the first question, for a newbie in cloud, how should I approach my legacy BI to get modernized with Azure Data Lake solutions? What are some key parameters I should consider?
Sure, that's a how long is a piece of string question. I guess the first and foremost is you need to have a strong business requirement that needs to get here. I mean, for the most part, the easiest way to show the benefits of the cloud is to show the cost savings, the significant cost savings, both in terms of running your infrastructure as well as the FTEs required to make sure that it keeps going, right? So that typically builds the business case really simply. And like I said, what you want to do is focus as much on the platform as a service and software as a service technologies as you can. It gets you away from needing to create servers and patch servers and worry about SQL versions and things like that. These vendors that offer their services as platform as a service worry about all of those things for you, and you get to focus on building applications. It really makes it. It's a compelling argument. The mistake I see made very often is the lift and shift approach. Though that works for some organizations, when you're moving to the cloud, it really is an opportunity for you to modernize your platform. There's a lot of customers who, and for some it's a valid path, but in the majority of cases, you end up having to do, the modernization at some point anyway. A lot of people lift and shift their architecture, so they take their servers on premise and put them on virtual machines in Azure. And like I said, it's a perfectly valid path, but there really is the opportunity to modernize along the way. And it's not an easy field to navigate. There's a lot of new technologies that come and go all the time. Unfortunately, there is no silver bullet. I wish I could give you one, but it really is horses for courses. So the best thing that you can do, this is not a sales pitch, but engage with vendors out there, even if it's just around helping you navigate that and then getting you on your way to a cloud migration. That's probably the first step, I'd say, is talk to someone who's experienced in this space, because there is a lot to consider. Hoping that I answered your question.
Okay. What are the prerequisites or technology to know to learn Data Lake?
So the technology, there's no real requirement to learn Data Lake, right? I mean, a lot of it is theoretical. And if you go and have a look at my blog post, I'll talk to you about. There's a blog post that I wrote in there about how you define lakes and what they actually mean and how you structure them and what the zones need to look like and what the data typically looks like in each zone. ADLS itself is a fairly simple construct, right? With a lot of parallels to traditional file systems that you see on an everyday computer, right? It's no different from that. Yes, it works in a highly distributed file system, and there are storage tiers and hot and cold tiers and things like that. But because of the platform as a service nature of it, you don't have to worry about that. Microsoft takes care of managing the actual physical storage layer. You interact with it as if it's just this endpoint, and all the magic happens behind the scenes. So in terms of scaling up, I'd go to the Microsoft documentation. It literally is not going to take you more than a day or two to read through the entire ADLS, basics stuff, and that will get the vast majority of people going within a day or two. It is a fairly simple technology to pick up, but one that has immense value to your organization.
Okay. Is it possible to use Delta Lakes from Azure Data Factory or Data Factory Data Flow?
So I have it on good authority. I'm pretty sure that the Delta Lake support for data flows in Data Factory is in preview at the moment. I don't think it's actually GA yet. I will have to check on that. I know that they're definitely working on it, and there's a number of other teams. The Azure Synapse Analytics team are also working on it for the serverless compute to get Delta Lake as a supported file format inside Synapse Analytics. And as you know, Synapse Analytics, the orchestration component for Synapse Analytics, is just used in Data Factory behind the scenes. So if that's working, then it's definite. If it's not there already, it's on the roadmap, or they're working on it actively. It's become a pseudo standard file format because of the ACID nature in which transactions are dealt with. It solves a lot of the problems of traditional data lakes. So it's a very sensible file format, and it's gaining a lot of traction in the open source community as well.
Okay, and last but not least, can you put up your website and blog details again for the attendees?
Absolutely.
Okay, now just to remind everybody, this session has been recorded and will be made available on the DBA Fundamentals Archive website. Excuse me. So if you miss it now, you will be able to come back and get these details to assist you with your further learning with the Delta Lake. So if we don't have any further questions, I'd like to thank Gerard for his time this month and spending that with us and taking us through today's session. I'd like to thank all of the attendees. As mentioned, this is the last session for the year, so I wish everybody a fantastic festive season. Stay safe, and I look forward to seeing everybody again in January for the new start of the 2020 season for DBA Fundamentals Down Under.
Thanks, everybody. Thanks, Warwick, for hosting.
You're welcome. All right, everybody. Thank you.